Hello, my name is Rady Alvarez, and today we will be going over the State Globin headquarters, and we will be doing a life cycle assessment. Myself, Elwin, Nissan, and Novak will be determining certain characteristics about the building. Before we jump into what the LCA life assessment is, really, we're gonna go over some things that we will go over. So first, we're gonna go over the building overview, then go into life cycle analysis, and then talk about our functional unit really, and then go into envelope and material research. Um, Going into the building overview, um, basically, so Seikoman has a reputation for being one of the companies at the helm of sustainability. The company is known worldwide for its accomplishment within the construction realm and has evolved from a company in the 1600s that only makes glass to, which was a very high tech, cutting edge technology for the time, to creating and producing high tech building and materials. So it's very important for them to also be sustainable in the way that they try to portray their business. So, I mean, just a little bit background about the building. About 200,000 employees they have worldwide, so it's a pretty massive company. Um, we will go into the stages of life cycle analysis right now. So, looking at what the life cycle analysis process is. So, first thing we want to do is establish scope. So, set a goal and clarify the scope of analysis. The second thing is life cycle inventory. So, account all inputs and outputs for each part of the life cycle. Third thing is impact assessment. Determine impact that each output made to the environment. And the last thing is interpretation and conclusion. So concluding and implication, realize, draw recommendations. So this is the part where we look at the LCA and say, hey, there's concrete or whatever the material may be, and this is how we can take away the concrete and do this material instead, and this will have a very big impact. So that's going to be the last stage. I'm going to pass it on to Elwin now. So thank you.
Hi, I am Lynn. This is slide 7, section 3, functional units and system boundary. I will explain about the functional unit and system boundary. Slide 8. The functional unit or the building is a lifespan of 60 years. We will use that 60 years lifespan to calculate the impact of the building on the environment and also the energy demand of the building. The graph shows the structure system boundaries of the exterior and interior. The boundaries are taken from cradle to grave. The stage usually include 4 main stages. They are manufacturing, construction, use, and end of life. This is slide 9, section 4. This is about impact categories. Okay, slide 10. These are the impact categories. The first one is the global warming potential. It is mostly the measurement of greenhouse gases trapped in the atmosphere. And another one, acidification potential. It is the measurement of elevated hydrogen concentration in sulfur outside, nitrogen outside, and those kind of gases. Ozone depletion potential, ODP. It is the measurement of all emission and chemical. Another one is EP. EP is the level of nutrient in a given body of water. Primary energy demand is the measurement of energy demand of the product. It is the important one. By using daily software, we can analyze and calculate those impact categories. Slide 11, Envelope Exterior Interior, Section 4. Slide 12, Building Scope. This is the scope of our project. We only had one skull because we analyzed exterior and interior together. Our building skull includes walls, window, door, ceiling, floor, and roofs.
Slide 13 discusses the level of environmental impact that each category holds over each stage of the life cycle. It shows here in this graph that manufacturing takes the majority of the environmental impact for two categories, namely the mass and the ozone depletion potential, while the operations reign supreme for all of the rest of the stages. Now, compared to these two categories in each of the stages where they reign supreme, all of the other categories seem to be minuscule and almost negligible by comparison. It's only maintenance and replacement that seems to hold any significance by comparison, but that itself is a distant runner-up, I should say, for nearly all of the categories. Slide 14 breaks down these results by division. All the shades of red shown in this graph being represented by manufacturing, while all the shades of gray being represented by operations. And once again, we see the impact category of mass being largely affected by manufacturing. And you see categories like global warming potential, primary energy demand, and non-renewable energy to be primarily dominated by operations. In slide 15, we break down these same results by material this time. Here, the impact levels seem to be much more varied. It seems to be this time masonry, the material masonry, that takes up the majority of the environmental impact for at least most of these categories, specifically mass, which seems to take up more than half of the entire environmental impact. And you see acidification potential, eutrophication potential, global warming potential, and smog formation potential, in which masonry takes up a plurality of the environmental impact. Ozone depletion potential is primarily taken by metals, and openings and glazings take up a good portion of renewable energy, non-renewable energy, primary energy demand, smog formation potential, global warming potential, eutrophication potential, and acidification potential. In slide 16, we show the Revit categories and all the results of each life cycle stage taken by these Revit categories. There is a big slice of each of these pies that is shaded in red. That red represents walls, which seems to hold the biggest impact over these categories, over all the other categories, that is. It's also exemplified in slide 17, which shows in this table that walls hold most impact for the majority of these categories, especially mass, once again. So based on these results, our plan for the next phase in this project would be to choose 3 alternative materials for the building so as to reduce the environmental impact that we've shown through these results. And we plan on falling in line with the guidelines of LEED in terms of materials and help with HBDs. And with that, we'd also like to analyze the materials with the bees tool and hope to take it from there. Thank you for listening.